Hello, Riles. Let's take a look at some options that we have when working with quadratics and see if we can find opportunities to use some of our new skills. So imagine a question says, find the optimal value of this quadratic f of x equals -2 times 3 minus x times x plus 5. So we have a lot of different options for how to do this. But at this course level, what we're looking for is efficient approaches. Okay, you can keep in mind that if you had enough space and enough time, you could figure this out using any method at all, but we're not going to have as much space or as much time as we want. We're expected to develop efficient solutions. So start to recognize the different formats. I recognize that this format right here is in a type of factored form. It's not the best factored form for us. I'll talk a little bit about that, but it is definitely in a factored form, which means I should be able to spot the values of x that make my output 0, which means I can find my x-intercepts. Okay. From factored form, I'm going to state that my x-intercepts occur when my roots are equal to 0. So I'm going to have an x-intercept when 3 minus x is equal to 0. And notice, this is what makes this maybe not our favorite factored form, is because of this rearrangement right here. Students that try to just memorize that, oh, I've got an x-intercept of -5 because it's the opposite of that, will often tell me that there's an x-intercept of -3 here. And that's silly, because if x is -3, this factor won't be 0 and this factor won't be 0. Now, there's always a way to show your work so that you don't have to remember things. The other way that I could have a root for this function for f of x equals 0 would be if x plus 5 were equal to 0. I can show my work, and that's why -5 is going to be an x-intercept here. Now, it's very important for you to announce what it is that you are calculating. That's part of showing your work. Announce or label what you're calculating. Because if I write this down, this is false. X is variable. X can be any number I want. X is not 3. X is not -5. This isn't an equation that I'm asking us to solve. X represents an infinite number of possible real numbers. As soon as I say these are the x-intercepts, my reader says, oh, I get it. You're telling me the values of x that will give me y values of 0. Now, why was I doing that if I was asked to find the optimal value? Let's use our sketch to help visualize things here. And say, if I could figure out that this curve has an x-intercept of -5 and +3, then whether it opens up or down, I'm pretty sure that the axis of symmetry is going to be halfway in between them. And that's a pretty fast way of finding the optimal value, because once I know the axis of symmetry, I can figure out the optimal value. Watch me announce that I'm going to find my axis of symmetry. I do it like this. I say, I am finding the axis of symmetry. The axis of symmetry is not a number. It's a line. Its equation is going to be given by like we developed in lesson 1.9, we developed a shortcut for the axis of symmetry from standard form. But I don't think that's going to be a shortcut if I can just see what the roots are. I think it's faster to just say my axis of symmetry is going to happen halfway between the roots, or at x equals -1. Once again, let me remove these labels and watch how my solution makes so much less sense now. So I have a variable function here, and I'm saying x equals 3. Just kidding. X equals -5. Just kidding. X equals -1. Like this is nonsense. X is not -1 for this function. This function, this relationship, has an infinite number of possible inputs and outputs. I have to say this is the axis of symmetry for what I'm writing down to make sense. And once I know my axis of symmetry, I can find my optimal value by just figuring out the output from this machine when my input is -1. So f of -1 is going to be -2 times 3 minus -1 times -1 plus 5. Now watch the symmetry here. I didn't point this out, or I usually don't point this out in class, but there is a type of symmetry that will happen here. When I get 3 minus -1, I'll receive +4. When I do -1 plus 5, I'll receive +4 as well. And I take this to completion, I get 16, -32. So this may be a surprise to students if they thought, and I'd avoided this conversation, if they thought that this curve was opening down because of its leading negative. Once again, because of this reversal here, this reversal means that my a value actually isn't -2. I'll convince you of that fact elsewhere. But I trust my algebra here. I have a vertex at -1, comma, -32. My directions were to find the optimal value. I found the optimal value. And this can go very quick if I wasn't explaining what I was doing. Okay. Compare that to a different approach, a student that says, no, I know a vertex or axis of symmetry shortcut, and they decide to expand this to standard form. They would probably want to do, I'd be careful here because the order of the multiplication is a little bit different. I think I'm going to show all four products. 3 times x plus 3 times 5 minus x times x minus x times 5. I'm always going to collect first in here before distributing through. I might try to put it closer to a standard form now. Minus 2x plus 15 there. And then if I expand through by -2, watch what happens out here. I get a positive 2x squared plus a 4x minus a 30. So yeah, my leading coefficient is positive. This curve actually does open up. And there's a -1 there and a +1 there and a -2 there. My a value, hard to see in this format, but maybe I don't need it. My a value is +2, which means it opens up. The reason why maybe I didn't need it is I could always use another test value like my y-intercept. Sorry, I'm going back in time here. My y-intercept f of 0 is going to be -2 times 3 times 5, which is going to be 15, -30. So that lets me know if I have a curve that has x-intercepts there and a negative y-intercept, it has to open up. Okay? I'm not going to let that negative out front confuse me. Just because there's a negative out front doesn't mean it opens down. That's not what we're supposed to understand. Okay, so back on task. I was given a function that was in factored form, and I said, yeah, I like the vertex express shortcut. I like the formula. So I have to take what? Maybe 1, 2, 3 lines to expand it. Then I get that the axis of symmetry is going to be given by the formula -b over 2a, which is going to be -4 over 2 times 2, which is going to be -4 over 4, which is going to be -1. While I kind of had that faster. Like if I look at my lines of work, even showing these steps, I've got like, I don't know, that much work to get my axis of symmetry versus this much work to get my axis of symmetry. Should a student that does this and then figure out their optimal value, f of -1 equals, let's say they substitute into standard form, should they receive the same mark because they get the same answer? Often students want to argue yes because probably they want their mark to be high. But to me, it demonstrates they're missing something. To me, a student that does this is demonstrating that not that they understand how to use this axis of symmetry formula. They're demonstrating to me that they don't understand factored form. They're also using more time and space than I would have budgeted. And it's okay if we're not using like the fastest approach on every single question, but often students end up using the slowest approach on every single question. And that's when they find that they're actually challenged for time. See, we know that students process at different rates, and that's okay. But if a student isn't developing efficient skills, it's not more time on a test that they need. It's more time with homework and with practice and with extra help that they need to develop efficient skills. Right? I guess we could take this sort of to an extreme and say, well, what about from here if a student said, well, I'm just always going to complete the square. So I'm going to expand this into standard form, and then I'm going to complete the square. They should get the right answer, right? But are they demonstrating the same level of understanding as a student that just recognized I have the x-intercepts, so why don't I just use them? I would say no. Like, do we need, this is why I'm nervous when a student asks for more space for a test question. Completing my square there. I mean, it's also good. I like encouraging students to check their answers, but I don't think you should feel the need to do this question in 3 totally different ways. If you choose to do that, I think you should strive to complete all of the assigned questions on a quiz or a test first before going back and checking. Minus 34. Whoops. -32. Why did I get? Oh, that changed to a 32 accidentally. There we go. because all of my answers should be the same. I forgot to conclude that this right here was me finding the optimal value. And then I guess from here, I would say my optimal value is -32. Okay, so look at this solution, and like I welcome argument about this. If you were asked to find the optimal value of this function and you expanded it to standard form, taking 1, 2, 3 steps, and then completed the square, taking 4, 5, 6, 7, 8 steps, maybe you can do that faster, but you've demonstrated by doing that, you've actually demonstrated that you don't understand how to use factored form, and you don't understand that we now have a shortcut for you don't understand factored form, and you don't understand how to use the shortcut from you don't understand factored form, and you don't understand how to use the shortcut from standard form. Sorry. Okay, look for efficient solutions. We'll talk more about efficiency when we start solving quadratic equations. There shouldn't be, you shouldn't just be saying, this is the one method that I like best, and I'm only going to work on that. It depends on what situation you have. Imagine in this question, I gave you the function in standard form. I think this would be the most efficient way. It didn't seem to take too long. Oh, I mean, imagine I gave you a function that was in vertex form and I asked you to find the optimal value. That should be like a fill in the blank question. Can you imagine a student that expands that to get it into standard form so that they could use the vertex shortcut? It's not a shortcut if you didn't start in standard form. Okay, so think about your approach.